Hello, this is the question of physics, and on 2016 there was a discovery of gravitational wave. So this question is the similar. If a small mass is dropped from a height h capital, and it gains kinetic energy on reaching to the ground, it could be converted into electromagnetic radiation. Photon can then convert it into mass. So conservation of energy, why a photon must be affected by the gravity. So if there's a gravity, there's a mass. Mass fell to ground. Potential energy. Potential energy is converted into a kinetic energy. Kinetic energy is then it can be converted into kinetic energy, and this one converted into photon. And photon, so mass is converted into photon, and photon can be converted back into mass. Then mass is dropped again, and it can convert into energy. And then, if it is a repeated experiment, there will be massive increase in the potential, increase in the energy because of the gravity. Photon frequency is 2.4 in 10 to the power 14 hertz, emitted toward the ground from a satellite orbiting Earth at the height of 450 kilometers above the surface. Uh, then the photon, if the photon is accelerated by the gravity, g acceleration, calculate the change in the frequency. So the photon, so this is Earth and this is satellite. Photon is dropped, and it has a potential energy gain. So energy at the ground is equal to energy of the satellite multiplied plus the potential energy mgh. So HF is the energy, the F is the ground frequency, HF is the satellite, plus HF over C square is the mass multiplied by GH. So HF satellite is common in these two. So HH blank constant is cancelled. So that is equal to F ground is minus F of satellite is equal to, and this is multiplied F into GH over C square. So this difference is F is which is this one multiplied by 9.8 at height is 4.50 kilometer divided by C square. So this is equal to 20 kilohertz. That will be the difference. When the photon travel 450 kilometer toward the Earth, how many wavelengths of the light would be this not affected by the gravity if it is not affected by the gravity? Number of the wavelength n is equal to distance by the wavelength. C, so lambda is equal to C over F. So distance is 450 kilometer divided by wavelength. Wavelength is a C over F. So this is equal to 6.1 in 10 power 11 wavelengths. If the photon is affected by the gravity now, so with the gravity, how many wavelength will be now? So if it is a gravity, the change in frequency is delta F is proportional to the height. So very small, so relative to the frequency. So wavelength also be linearly to the linear to the height. So wavelength reduces as photons approaches to the ground. So what is the change in the number of complete wavelength along the 450 due to the gravity? So this is the argument, and then n with the gravity and dash with the without gravity, which we have enumerated. So the difference is multiplied by time into this change f satellite plus delta f by 2 minus f delta t multiplied by satellite. So this cancel. This is equal to delta t delta f by 2. So delta t is a 2.5 in 10 to the power 5 time, which we have measured already. So from here, so from uh, yes, distance divided by the time. Distance is 4.5 kilometer. So multiply by the delta F, which is a 2026 divided by 2. So that will be equal to 15. So the difference is only with gravity and without gravity is 15 wavelengths. This is very important results. So how the gravity effect on the photons and gravitational waves.